Hello, good morning, my dear students. This is Surya Anand, chemistry teacher. Welcome in my channel, Chemistry Wala Anand sir. So I come with the today video. This is the chapter number 4 of structure of the atom, and this is the class of chemistry of class 9. So my dear students, welcome in my short today. This video today. This is the first topic is the structure of the atom. So we discuss the structure of the atom as we have learned. We are discussing the structure of the atom. Let us understand this first. According to the Dalton's atomic theory, the atom was indivisible. First one, and indestructible. That is not going to be divided. It is not going to be destruct. But the discovery of two fundamental particles, that is electrons and that is protons, inside the atom led to the failure of this aspect of Dalton's atomic theory. It was then considered necessary to know how electrons and protons are arranged within an atom. It is very important that how electrons and protons are arranged within an atom. For explaining this, many scientists proposed various atomic models, but J.J. Thomson was the first one. J.J. Thomson was the first one to propose a model of the structure of an atom. So J.J. Thomson of the model of an atom explain this is the Thomson model of an atom, electron and positive charges. An electron is electrically neutral. It contains positive charges of the presence of proton as well as negative charges due to the presence of electron. Thomson explained that assumed that an atom is a uniform pair of positive charges with electron embedded in it. The atom may be thus visualized as a pudding of cake or watermelon of positive charges. In some book you can see the watermelon in NCERT. Within the resins, electrons embedded in it. There is electrons embedded in it, positive charges there, electron embedded in it. This model of the atom later come to know as the resin pudding model. So this model, resin pudding model, explains the electrical neutrality of the atom but fail to explain how these fundamental particles were arranged in the atom. Especially the free positive and negative charges are close to each other. So let us understand these things in a clear explanatory way. So what was the Thomson proposed? According to the Thomson? What was the Thomson proposed? How we just conclude the Thomson model? If we want to conclude the Thomson model, let us take a brief look how the Thomson tried to conclude the Thomson model. What are the conclusion? So at last I am going to tell you about the Thomson model, that how Thomson will conclude this model. So the Thomson model of an atom. Thomson model of an atom Thomson's model of an atom. Thomson model of an atom. How Thomson is going to conclude? So Thomson proposed that. How Thomson proposed that the 2 points. The Thomson is going to propose the 2 points only. The first point Thomson says. An atom consists of a positively charged sphere and the electrons are embedded in it. And the second point Thomson proposed that the negative and positive charges are the negative and positive The negative and positive charges are equal in magnitude. Are equal in magnitude. So, the atom as a atom as a the atom as a whole, numerically as a whole, is electrically neutral. Electrically neutral. Although Thomson model explained that, Thomson model explained that, atoms are electrically neutral. Although Thomson model explained that electrons are electrically neutral. The result of experiment carried out, carried out by other scientists, could not be explained by this model. Could not be explained by this model. As explained by this model, we can see in the further model. So the Thomson will explain the atom is neutrally neutral. It contains positive charges due to the presence of proton as well negative charges due to the presence of electron. So the Thomson assumed that atom is a uniform pair of positive charges with electron embedded in. This is the main model. This is the main point of the model. Okay. But the atom may be visualized as a padding of cake or watermelon. You can see in the NCERT of positive charges with resins, electrons embedded in it. The electrons are embedded in it and the positive charges. This model of the atom let us come to know as the resin pudding model. This model explains the electrical neutrality of atom. The second point I explained, but failed to explain how these fundamental particles will arrange in the atom, especially the free positive and negative charges too close to each other. So Thomson proposed that atom is consists of a positively charged pair and the electrons are embedded in it. Second point, the negative and positive charges. The negative and positive charges are equal in magnitude. So the atom as a whole electrically neutral. Although Thomson model explained that atoms are electrically neutral, the result of experiment carried out by other scientists could not be explained by this model. So these are the Thomson model. So let us look about the Rutherford model of an atom. Let us understand the Rutherford model of an atom. How can we explain the Rutherford model of an atom? How the Rutherford research on the atom and about the structure of atom, that according to the Rutherford theory, according to the Rutherford practical experiments, how Rutherford assumed and proposed this model structure of atom. So let us understand the Rutherford model of atom. So my dear student, I always try to teach you, I always try to mentor you. I am not as a teacher, I am your mentor. I always try to explain you, I always try to give you the explanation on the behalf of NCERT contents. In my contents there is few NCERT alpha particles. So Rutherford model of an atom, discovery of the nucleus. There is speculation as to how protons and electrons are present inside the atom was a matter of debate for a long time. The neutrons had not been discovered. Then in 1911, scientist Ernest Rutherford of New Zealand gave a new picture for the structure of atom by his alpha particle scattering experiment, proposed the existence of a nucleus in the atom. Alpha particles are charged. Alpha particles are charged particles, charged particles having 2 units of positive charge and 4 units of mass and 4 units of mass, that is alpha particles are doubly charged helium atoms, charged helium atoms, that is at He2 plus. These are produced from radioactive source, produced from radioactive sources such as radium. So my dear students, let us understand these things in a very simple way, in a very easy steps. So my dear student, it is going to be quite clear. So the Rutherford's model of atom, the next model of atom is the Rutherford model of atom. So the Rutherford model of atom, let us understand the Rutherford model of atom, the speculation as how protons and electrons are placed inside the atom was a matter of debate for a long time. The neutrons had not been discovered yet or then. In 1911, scientist Ernest Rutherford of New Zealand gave a new picture for the structure of atom by his alpha particle scattering experiment and proposed the existence of a nucleus in the atom. So the alpha particles are charged particles having a 2 units of positive charge and 4 units of mass. That is alpha particles are doubly charged helium atoms, that is the He2 plus. These are produced from radioactive sources such as radium. So these are the things, the Rutherford model of an atom. Let us understand the Rutherford experiment by the picture, by the Rutherford's experiment. So my dear student, let us understand the Rutherford's experiment in a explanatory way, step by step. These are the things you have to be, these are the introduction of Rutherford experiment, and these are the whole experiment, how it happened, how it should be, how it was done. We can explain it briefly and we can explain it in the explanatory way. So the next part is our Rutherford's experiment. How the Rutherford is going to be experiment the alpha particle radiation. So let us look. The arrangement of the alpha particles, the arrangement of the alpha particles, scattering experiment, is shown in the figure. The alpha particle experiment is shown in the figure. There is a box. There is a box is there. And after that there is a After that, there is a three radiations from here. One, second is the space, and third is the, and it should be embedded on the point. Alpha particles. These radiations go the straight line. Go in the straight line, and that pinch upon in the long way, and there is this way, this way, this way, this way. This is the alpha particle radiations. Okay. Alpha particles radiation. And in the alpha particle radiations, there is a diagram. I can draw it here. From the NCERT books. Touching on it. The diagram should be like this. And after this there is also this will come here, and like this, and this is the gold foil. Gold foil, the spherical screen, and these are the alpha particles, source of alpha particles. These are the sources of alpha particles, and the figure is known as scattering of alpha particles as by gold foil. Figure is scattering of alpha particles. Figure is scattering of alpha particles by a gold this experiment done by the Rutherford. So my dear student, let us understand this experiment. Rutherford produced a narrow. Rutherford produced a narrow beam of alpha particles. Beam of alpha particles from a radioactive source. From a radioactive source, example radium or polonium, polonium, and allowed it to strike, I draw the diagram first because this diagram will try to explain it clearly. The arrangement of the alpha particle scattering experiment is shown in the figure. This is the alpha particle radiation given by the Rutherford. There is a alpha particle source of alpha particle is there, and that is going to be radiated in the gold foil. And this gold foil is spherical is scattering of alpha particles by gold foil. Rutherford produced a narrow beam of alpha particles from a radioactive source that, for example, is radium or polonium, and allow it to strike and extremely thin gold foil and extremely thin gold foil. Is it clear? After that, the emergent beam of alpha particle, the emergent beam of alpha particles was then allowed to fall on a spherical screen coated with zinc sulfate, that is ZnSO4. So my dear student, Rutherford expected that if the spherical model proposed, earlier which made for a uniform distribution, equal distribution of positive and negative particles was correct. Then the alpha particles striking the gold atom, would be uniformly distributed. After that, however, he observed the following. He observed the following. So let us understand it in a clear way. The arrangement of the alpha particle experiment is shown in the figure. This is the alpha particle scattering source of alpha particle, and the spherical skin. This is a gold foil. And Rutherford produced a narrow beam of alpha particle from a radioactive source, that is the radium or polonium, and allow it to strike on an electrically extremely thin gold foil. The emergent beam of alpha particle was then allowed to fall on a spherical screen coated with the zinc sulfate. Coated with the zinc sulfate. Rutherford expected that if the spherical model proposed earlier, which made for a uniform distribution of positive and negative particles was correct, then the alpha particles striking the gold atoms would be uniformly distributed. However, he observed the following, but he will observe the following things in the next way. So my dear student, let us understand the what does the Rutherford, what observation will Rutherford saw, what observation seen by the Rutherford. So let us understand the few observation observed by the Rutherford. So my dear student, let us understand the next diagram by the Rutherford explanation. What does the Rutherford explain? What does the Rutherford saw? Okay. So my dear student, let us understand these things. So I am going to rub the picture. So because there is another picture is there, I am going to make it. So the Rutherford experiment is not too much hard. It should be understand very easily step by step. So I am going to give you the clear picture today of Rutherford model. So let us understand these things. So the Rutherford understand the Rutherford, however he observed the, however he observed the following. Observed the following. What is observed? First point. The first point he observed, the most of the alpha particle passed straight. Most of the alpha particles passed straight through the gold foil without, through the gold foil without suffering any deflective, without suffering any deflection from their original path. Deflection from their original path. So however he observed the following things. Second thing he observed that a few of them were deflected. A few of them were deflected. Okay, a few of them were deflected through small angles. Through small angles, and whole a very few were deflected. Whole a very few were deflected to a large extent. The last observation he saw that a very small percentage, 1 in 10,000, 1 in lakh, 1 in lakh was deflected through angles, through angles ranging from 90 degree to 180 degree. And the diagram for this observation I am going to draw. The diagram for this observation I am going to draw. This is the nucleus atom, and these are the nucleus. I am going to draw. Fourth line is there. And the last line is going to be deflected in the straight line again. In the straight line. So this is the scattering alpha particles by Wolfman. Figure, this figure is also scattering of this is the second figure. There is the two figure important for the explanation. This is the figure number 2. So these things will happen. Most of the alpha particle pass through straight through the gold foil without suffering. Most of the alpha particles passed straight through, straight 1, 2, 3, 1, 2, 1 and 2 straight through the gold foil without suffering any deflection from their original path. 1, 2 is going to be straight. A few of them were deflected through small angles, only very few were deflected to a large extent. There is deflected a small angle, this, and this is the no deflection. In a straight line, this is in a without suffering from deflection straight. This is straight, a small deflection. It is going to be for understand. And this is a view very small percentage, 1 in 1000 is going to be deflected to angle 90 degree to 180 degree. 90 degree, this one, and this is 180 degree. 90 degree to 180 degree. So these things were to be done. So my dear student, let us understand these things in a brief. And I am not going to give you the lengthy notes. I am giving you the main points and the things you have to be right in the examination. Rutherford model of an atom, you can write the Rutherford model theory and then after the experiment. So the Rutherford will explain. Rutherford then proposed a new picture. Rutherford then proposed the new picture. Rutherford then proposed a Rutherford then proposed a new picture of the structure of the atom, of the structure of the atom. His model is known as Rutherford model, Rutherford nuclear concept of the atom. Rutherford's nuclear concept of the atom. Okay, the main feature of this model, the main features of this model. Any questions come from the Rutherford model of an atom, you can write the answer. I am giving you the answer. So, main model, the main feature of this model are as follows. Of this model are as follows. The main feature. The main feature of this model are as follows. The first point, very important. The atom of an element consists of the atom of an element. The atom of an element consists of a small positively charged. Consists of a small positively charged. Small positively charged nucleus. Nucleus which is situated at the center of the atom, at the center of the atom, and which arises from, which carries almost the entire, which carries almost entire mass of the atom. Mass of the atom. Second point of explanation, the electrons are distributed in. The electrons are distributed in the empty space of the atom, in the empty space of the atom around the nucleus, around the nucleus in different concentric paths called orbit. Paths called orbits. Third point is the number of electrons. The number of electrons in orbit is equal to the number of positive charges. Number positive charges, that is protons. Protons in the nucleus. Hence, the atom is electrically neutral. Fourth point is the volume of the nucleus is is negligibly small as compared to the small as compared to the nucleus compared to the volume of the atom, sorry, volume of the atom. And the last one, not the least, most of the space in the atom is empty. Most of the space in the atom is empty. Okay, so let us understand these things in a clear way. So Rutherford experiment is, we are going to conclude. Rutherford then proposed a new picture of the structure of the atom. This model is known as Rutherford nucleus concept of the atom. The main feature of this model is the atom. The atom of an element consists of a small positively charged, that is called nucleus, which is situated at the center of the atom and which carries almost entire mass of the atom. Second point, the electrons are distributed, second feature, distributed in the empty space of the atom around the nucleus in different concentric paths called orbits. Third point, the nucleus of electrons in orbit is equal to the number of positive charges, protons in the nucleus, and the atom is electrically neutral. Fourth is, the volume of the nucleus is negligibly small as compared to the volume of the atom. And fifth is, most of the space in the atom is empty. So this is all about the, today we discuss the two things. Today we discuss two things, and the discussion is going to be concluded. After that we look at the drawbacks of the Rutherford model, and after that neutron and some electronic configuration, and the chapter is going to be complete in 2 days. So my dear student, this is all about today. Today we already discussed the structure of an atom, the Thomson model of atom, and the Rutherford model of atom, Rutherford experiment, in a brief explanatory way. So thank you for watching my video. This is Suraj, chemistry teacher. Welcome to channel Chemistry Wala Anand sir. Give more views, share it to the student of more and more to the class 9, because the examination will be start in few days. So my dear student, that's why I am giving you much more time. So my motivation is only give, share, like and views, and also subscribe my channel. Want to learn the chemistry in the simple and easy step, that come to join my channel Chemistry Wala Anand sir. Give more views, like and share. Thank you all of you. Take care.